1, 2, 3, 4!
Okay, so here's what we're going to do here. We're going to solve this equation when I unfreeze it. I didn't know what to call it, so we're solving it when the exponent's still a variable. But I'm going to try to mess around with this because I'm going to see if I could change this term right here. Now, usually on some of the exams, they give you a little hint. And I'll write the hint down here. And they'll say something like, and if they don't give you a hint, well, you can remember this one. They'll say, use something to represent 2x and 2 to the power of x. All right, so where does that help me out? It helps me out right here, but remember way back when I said if you can rewrite something, rewriting the powers with the same base, try to do it. And I can see something like that going on here because 4 is 2 squared. All right, I can use m right here, so I'm going to say, okay, I can. That's pretty clear. But before I do that, I go, well, okay, I do know that 4 is 2 squared to the power of x minus 2 to the x minus 30 equals 0. Good thing it's set to 0. And pretty soon it's going to start to look like a quadratic. And I'll show you how. Remember how that we talked about earlier, how a power to a power gets multiplied, and multiplication is commutative. So what I mean is that 2 times x is the same as x times 2. Now what I'm going to do, and this is algebraically legitimate, is I can swap these things and call that 2 to the x and make that squared. And I just did a little swap there, and that's completely cool because the order I multiply doesn't matter. Well, now what I can do is now I can use that substitution right here. So if it gives me this hint, it says, okay, let m equals 2x. Well, that means that there's m right there, okay, and it's squared. And there's m right there, because that's 2 to the power of x, and that's just m. And with that hint, and with that tricky little thing there, this equation here becomes manageable. It becomes a quadratic. Yes, it's a quadratic that can factorize. So I can factorize this quadratic and get the solutions for m, not the solutions for x. I can factorize this quadratic. I'm pretty sure when I look at these and two numbers that multiply to get negative 30 and add to get negative 1 are... I should probably wash my hands while I do this. Solve for n. And that's, and I'll say now solve for x. Okay. And when I do that, okay, well, let's see, 6 equals 2 to the power of x. And I'm going to be using logs there, and I'll take the log of both sides and do my thing, but I'll just do my shortcut so that x will be equaling the log of 6 divided by the log of 2. That I know for sure. And I get some decimal there, 2 point something. Okay, so one solution is 2.585 to 3 decimal places. And now I solve for x in the other one. Okay, what about negative 5? So negative 5 equals 2 to the power of x. If you're keen enough with powers or exponents or logarithms, maybe some warning lights should start to go off, because powers work in a certain way, and you maybe if you don't know, you can go, okay, well, x equals log negative 5, warning lights, divided by log 2. This probably should have some brackets there. And I can't get the log of a negative number. So before you even pick up your calculator here, there's no value of x that will make this power a negative number. It's impossible. A negative x won't do anything. A negative x will just, negative 1 would make it 1/2. Negative powers don't make the base negative. Okay? So there is literally no solution here. No. Now when I say no solution, I mean no solution. Not even imaginary numbers would fix it there. No solution for x here. No solution for x here. Full stop. We can't. There's nothing that'll happen there. No value of x will make this negative at all. Okay. So my solution, by using that little tricky thing here, turning it into a quadratic, solving for m, and then using m to solve for x, if I had 2 positive solutions for m, then I'd get 2 solutions for x, but I don't. I just get 1. Okay? We'll try another example there and see if we can do that on our own. What do you think? Pretty good for excellence?